So question 1, let's say the functions f and g are defined as follows. Well, are defined by f of x is x squared plus 5 and x must be greater than or equal to 1, and g of x is equal to 4x minus 3 where x is x is a real number, where r is a set of real numbers. Right, so the way to find the value of g of f of 2. So we have space for that, so for that here. So this is 2015. Question 1a. 1a. Right? G f of 2. G f of 2. So by looking at this, you need to realize that this is a composite function. Right? Composite function. Right? So what you had to do here first, you go work out f of 2 first. Right? Well, that's why I could do it. So we got f of 2 first. So f of 2, alright, back to function here. So we had f of x is equal to x squared plus 5. And g of x is equal to 4x minus 3. 4x minus 3. So we find an f of 2 now. So wherever we see x over here, x squared plus 5, we're replacing x with the number 2. So you will get 2 squared plus 5. 2 squared is 2 by 2, which is 4, plus 5. Now 4 plus 5 is actually 9. So this is really f of 2. Now what you can do, you can replace the f of 2 with the number 9. So what you end up with is g of 9. That will be equal, on your right hand side of g of x, you're replacing x with the number 9. So it's only 4 by 9 minus 3. 4 by 9, I believe that will be 36. And your minus 3. 36 minus 3 is 33. Right? Well, this is g of 9. This is g f of 2. Right? 33. I believe that will be your answer there. That is one way of doing it. Another way you could have done this is just find g f of x, then find g f of 2. And you should get the same thing, 33. Right? Whichever method is easier for you. The next part, which is b. So the function is defined by h of x is equal to 3x plus 5 all over x minus 2, where x is an element of the real number. X cannot be equal to 2 because if we plug in x is 2 over here, the denominator will be 0. 2 minus 2 is 0, so x cannot be equal to 2. This is to determine the inverse of h of x. So we're going to rewrite that. So this is part b. So with the question state that h of x is equal to 3x plus 5 all over x minus 2. Right? So the first step here, this is like fixie marks here, is to replace the h of x with the letter x. Put back the equal sign on the right hand side, whereby you see x, replace it with the variable y. So you now have 3y plus 5 all over y minus 2. Then the next step is to basically solve for y. Now I can write x as a fraction as x all over 1. Because if I have the number 2, I could write 2 as a fraction, 2 all over 1. If I have the number 10, 10 as a fraction is 10 all over 1. Right? 10 divided by 1 is 10, 2 divided by 1 is 2. x divided by 1 is x. Right, so I write it x is a fraction, x over 1. What I'm going to do now is cross multiply. So what I'm going to say now is simply x multiplied by y minus 2. So y minus 2 has to go inside the bracket. That is equal to 1 by 3y plus 5. 1 by 3y plus 5 will simply be the same thing, 3y plus 5. But you really want to solve for y, yeah? So what we're going to do here now is expand out this. X times y and x times negative 2. So you'll get x, y, and x times negative 2 is negative 2x. That is equal to 3y plus 5. But we want to keep our y's on one side of the equal sign. Not so? So what I'm going to do here now is simply say xy minus 3y is equal, because I bring this 3y to the left hand side, it becomes negative 3y, is equal to, I carrying across this negative 2x to the right hand side, it will become positive. Positive 2x plus 5, which remain on the right hand side. What I could do, I could factor out what is common here, which is y. Y was common there in an open bracket. Xy divided by y is simply x. Put back your minus sign because you had a minus sign between the xy and the 3y. You put back that in the bracket there. 3y divided by y is simply 3. That is equal to 2x plus 5. But if you want to solve for the value, well, if you want to solve for y will therefore be 2x plus 5 all over, when you carry across this x minus 3 to the right hand side, you're going to have to divide. So you get x minus 3. The last and final step here now um, would be f inverse of x. So you're replacing y with f inverse of x, and that will be equal to 2x plus 5 all over x minus 3. And that is basically your solution, your answer for f inverse of x. Understand this? So one little minor change there, it was h inverse of x we was trying to get, not a f inverse of x. Right? So it's h inverse of x, which is basically the same thing. And here x cannot be equal to positive 3. Because if x is positive 3, 3 minus 3 would be 0. You got 0 as a denominator, which you do not want. So x cannot be equal to positive 3. Right? That's basically the answer there for that part. Parts B here now, let's say so we now do that. Right. Part C here now, they say given that x minus 2 is a factor of this function, k of x is equal to 2x cubed minus 5x squared plus x plus 2, the way to factorize this completely. So I'll go ahead and write back that on the next side here. Right. So that's here. Uh, so what we could do, we could say, well, this is what they give us, right? Part C, they told us that x minus 2 is a factor. Right? So what does that mean? That means that if you have x minus 2, you let that equal to 0. So x minus 2 would be equal to 0. Therefore, x will be equal to 2. Now that you get the value for x, if you were to plug in that into the k of x, you would get 0. Right? So you could say that k of negative 2 would therefore be equal to 0. Because x minus 2 is a factor, right? Simple. But here they say factorize this completely, which means that they would want the other factors, not so? Yes, that's what it means. They want the other factors, except Well, apart from the x minus 2, there were the other factors. Since that cubic equation, you would expect it to have 3 factors, right? So we gotta do a long division here now, right? So we know that k of x is actually equal to 2x cubed minus 5x squared plus x plus 2, right? So we do the long division. So we have x minus 2 outside the division symbol, and inside the division symbol what we have is the k of x, which is 2x to the power of 3 minus 5x squared plus x plus 2. So what we're going to do here now is simply the long division. So we can say the first term inside here, which is the 2x cubed, I'm going to put it here. 2x cubed divided by x. That will simply give it 2x to the power of 2. Because x cubed divided by x to the power 1, you subtract the power 3 minus 1 is 2, x to the power 2, and then, well, you had the 2 in front of x cubed, that will remain unchanged there. Alright, so we go and put that up here now. Alright, so 2x squared, 2x to the power 2, or 2x squared. What you're going to do now, you're going to say that value 2x squared, or that term, multiplied by the factor, which is x minus 2. They say 2x squared times x will be 2x cubed, and 2x squared by negative 2 will be negative 4x squared. So you can put in that here. So we put in 2x cubed minus 4x squared. What you're going to have to do now is minus coming down. 2x cubed minus 2x cubed would be 0. Right? Negative 5x squared minus negative 4x squared will simply be negative 5x squared minus negative 4x squared. But a minus and a minus in the middle will give a plus. So it's negative 5x squared plus 4x squared. That will give you negative x squared. You bring down your x plus x. You could also bring on the plus 2, nothing wrong with that. Then now you repeat the procedure. You say negative x squared divided by x. I'm not going to do all of that. So I'll just put the answer here, which is negative x. Because if you have negative x squared on top and positive x below, you could get negative x. Now negative x times positive x will give a negative x squared. Negative x times negative 2 is positive 2x. And then you subtract again coming down here. So negative x squared minus negative x squared will be negative x squared plus x squared, because the minus and minus is a plus. You get 0, the x squared term cancels. Now x minus 2x would simply be negative x, and then you bring down this plus 2. Right? So now you say negative x divided by x is negative 1. Negative 1 by x is negative x. Negative 1 by negative 2 is positive 2. And then you're minusing coming down again. Negative x minus negative x is negative x plus x, which is 0. 2 minus 2 is 0. So you have a remainder of 0. As we had stated previously. Right? If x minus 2 is a factor, therefore you have to let x minus 2 equal 0, therefore x is 2. K of negative 2 would be 0. You have a remainder of 0. That is the remainder. Remainder equals 0. And as we had seen here, this is our remainder. Right? Simple. So our other factors would have been basically this term here. We call that the quotient. So we can say that f of x is really equal to the first factor, which is x minus 2, multiplied by the other factor, which is 2x squared minus x. I believe it will be minus 1. Yes, minus 1. That's what I have up there. But wait a minute, this is only two factors. But this is a quadratic. This can be split up into two other factors. So what I'm going to do, I write them up the x minus 2, open my bracket. Now I look, well, yeah, basically factorize a quadratic here. Right? This is a quadratic in which you need to factorize. So look for two numbers when multiplied will give you 2 by negative 1, which is negative 2. And when added, will give you the middle term, which is negative 1, which is really b. So that is of the form ax squared plus bx plus c. Two numbers would be when added, it could be negative 1. Actually, it could be negative 2 plus 1, and negative 2 times 1 will give you negative 2. Right? So how you're factorizing that, you just put 2x squared minus 2x plus x, because that is like the factors here, negative 2 1 plus 1, right? But just you put x there, right? You combine it with x, and then you have the minus 1, which is the c. Then you factorize by grouping what is common here, 2x, open your bracket, 2x squared divided by 2x is just x, for your minus sign. 2x divided by 2x is 1, close your bracket. What is common here? 1 plus 1. Open your bracket. X divided by 1 is just x. 1 divided by 1 is minus 1. Close the bracket. So what you're going to get is 2x plus 1 times x minus 1. That's basically it there. So I could write it in, say, I could say x minus 1 multiplied by 2x plus 1. The order in which you write it don't matter. Right? But this is basically the factors of f of x. So that's the answer there. Right? So that is that there. Right? So let's see. Part D, let's say to solve this. Right? So we roll on to part D here now. So part D, what we had here, we have 16 to the power of, where's that one? It was x plus 2, and that is equal to what? 1 over 4. Right, so I could write everything here. I could write it to base 4, no problem with that. Right, I could write 16 in terms of base 4. Simply, I could say the square root of 16 will be 4. But if I square both sides, I'll get 16 will be equal to 4 to the power of 2. And this is really what I want. So now I could replace this number 16 here. I could have put this in bracket, no problem with that. Right, but I'm going to put back up and do. Right, so what I'm going to do, this is the given question here. Right, so what I would do in the next line, I would say 16 to the power of x plus 2 is equal to 1 all over 4. Now I can replace this number 16 with 4 to the power 2. So what I would have here now is 4 to the power of 2 raised to the power of x plus 2. And that is equal to 1 all over 4. And this is really 1 over 4 to the power 1. But if I bring the 4 to the power 1 on top, right, I will get 4 to the minus 1 by law of indices. Right, so what I would have here now is 4 in my brackets. But when you have a power raised to a power, it does multiply the powers. So you can say 2 times x is 2x plus 2 times 2 is 4. Right? So that's what I did. I multiply the power by the power. Right? So I say x plus 2 multiplied by 2 will be 2x plus 4. You distribute the 2. 2 by x and then 2 by 2. Basically. Right? And that is equal to 4 to the power of negative 1. Because if I bring 1 over 4 to the power positive 1, if I bring 4 to the power positive 1 on top, it will be 4 to the minus 1. So what you really have here is the same base on both sides, right? So same base, right, on both sides of equal sign, or the equation if you want to say that, right? So since the bases are both the same on both sides of the equation, right, we can equate the powers, right? So we can equate the powers, right? If we equate the powers, we will get the power on the left hand side, which is 2x plus 4 would be equal to the power on the right hand side, which is just negative 1. And the power of 4 on the right hand side, which is just negative 1. So we solve for x here now. So 2x is equal to negative 1 minus 4, because I carry across the positive 4 to the right hand side, it becomes minus. Therefore 2x is equal to minus 5. Therefore x is equal to minus 5 all over 2. And that's basically the answer there for that part, right? Minus 5 all over 2. And then the last part here, which is 4 marks, the log question. Right? So we're gonna write back the question here for the next part. I have to put that down here. Right? So we have log of x plus 2, and this is the base 3, right? Plus log of x minus 1 the base 3, right? So that will be equal to log of 6x minus 8 to base 3. Whatever we define, solve. When this is solve, we have to find the value of x, right? So let's see what we could do here. Put this in this color here. We are applying the rules of logs, right? So this is the addition of two log terms, right? So the addition of two log terms, if you have log of x plus log of y, this is a property that says you will have log of x times y. So we could apply that rule there, right? So this will simply combine to give you log of um, x plus 2 multiply by x minus 1. So if you're confused about this, just review your properties for logs. This would be the property here, right? The formula here that you use. Log of something plus log of something would be equal to log of the multiplication of the two somethings, right? Like that, right? And this is the base 3. Base remain the same in this case. And that is equal, for now, to log of 6x minus 8. And this is the base 3, right? So we can say by product rule of log, right? The shorthand. Now since the logs on both sides of the equation are the same, that is both sides have log to base 3, left hand side and right hand side, right? In other words, both bases are 3, in this case are the same. We can equate the terms. We can equate, let me show you what we can equate here. We can equate the x plus 2 times the x minus 1 to 6x minus 8. Right? In other words, what we could do, since we have log of something equal to log of something, we could remove log the base 3. If we remove that, what we're going to end up with is x plus 2 multiplied by x minus 1. That is equal to 6x minus 8. Right? That's what we could do there. Now we basically have a small little equation here that we could solve for. Right? We could use the distributive law, x by x, x by negative 1. What that gonna be working out to, let me see. So x by x is x squared, x by negative 1 is negative x, and then on top here now what we gonna have is 2 by x and then 2 by negative 1. So what we gonna have here now is 2 by x will be plus 2x, and 2 by negative 1 is basically negative 2. That is equal to 6x minus 8. So what we got to do here now is simply say negative x plus x will just be x. And then you have your x squared here. So you put back your plus sign between. Because you have x squared, that remains unchanged. And negative x plus 2x, negative x plus 2x will just give you x. Positive x, so plus x. And you put back your negative 2 here. And that is equal to 6x minus 8. Right? So what we're gonna do here now is simply bring across this x to the left hand side. We could bring across the negative 8 as well, nothing wrong with that. So what we gonna have here is x squared plus x minus 6x minus 2 minus 8, and that is equal to 0. Right? So we gonna have x squared minus 5x minus 10, and that is equal to 0. So we have here, this is let me see, did I do this correct? Mhm. Nope. When I bring across this negative 8 to the left hand side, it should have been plus 8. So negative 2 plus 8 would be positive 6. That is my little error there. So as you see, it's always good to check it over. Plus 6, and that's equal to 0. So now what we have here is a quadratic equation, and this is of the form ax squared plus bx plus c, and that is equal to 0. So we just factorize this, put our brackets there. We do the shorthand method. We put x here. We put x here. We look for two numbers when multiplied will give us, since the coefficient of x squared is 1, it's 1 by 6, which is just 6. Two numbers when multiplied will give us positive 6, and when added should give us negative 5, which is really b, which is our middle term. In my case, I am getting negative 3 and negative 2. Negative 3 times negative 2 is actually positive 6. Negative 3 plus negative 2 is actually negative 5. So you can put x minus 3 and x minus 2. Now, since the product of these two factors is equal to 0, then you have to let each of the factors equal 0 and solve for x. So x minus 3 is equal to 0. Therefore, x is equal to 3. And x minus 2 is equal to 0. Therefore, x is equal to positive 2. So x is positive 2 and x is positive 3. So we have two solutions for x here. Positive 3 and positive 2. Very, very important to know and understand how to solve log equations. Right?